Good morning everyone. Heartily welcome to my YouTube channel. So we all know that we are here to discuss the concepts of JEE. Already we have finished three concepts, right? Three topics related to JEE from matrices and determinants. So let us continue with that. So today's session is going to be a very useful and interesting session, right? So which is going to deal about adjoint of matrix. We are going to study about adjoint of a matrix. So adjoint of matrix is very important from your JEE or any state board state competitive corner, because so in order to this adjoint of A is a basic to find inverse of any matrix. Adjoint of any matrix is the basic to form inverse of any matrix. So inverse of a matrix is given by 1 upon determinant A into adjoint A. So if you have the value of adjoint A, directly you can calculate the determinant A. But in conventional process it takes a very long time. Why? Because you need to find minors of all the elements, you need to find cofactors of all the elements, then you need to form the cofactor matrix, and then you need to take the transpose, then you are going to get the adjoint of any particular matrix. But here in today's session, so I am going to tell you the trick which will be helpful for you for your JEE or any competitive part. Within 10 to 15 seconds, you will be able to find the matrix adjoint A. Once adjoint A is there, then it is very easy for you people to find A inverse. So without wasting time, let's start the today's concept. What is adjoint A? As I said, adjoint of any matrix A equals Aij is nothing but transpose of its cofactor matrix. So first if you need to find cofactor matrix, then if you take transpose, then you will get the value of adjoint A. That is nothing but the common definition or the definition of adjoint A through conventional method, right? So that is what it is defined here. Let A equal to Aij be the square matrix of order n, and let Cij be the cofactor of Aij. Cij is cofactor of Aij means C11 will be cofactor of A11, C12 is cofactor of A12, C33 will be cofactor of A33. So then transpose of the matrix of cofactors of element A is called adjoint A. So once you find the cofactors, put it in the form of matrix, take transpose, then you are going to get the adjoint A. That is what conventional method is, right? So if A is A11, A12, A13, so on up to A32 and A33, then adjoint A will be, so what is the definition saying? Cij is cofactor of Aij. So if I am having A11, its cofactor will be C11. A12, C12. A13, C13. So similarly cofactor of A33 will be C33. So C11, C12, C13, so on up to C33 is cofactor of matrix A. It is cofactor matrix of this particular matrix A. If I take transpose of this matrix, then I am going to get the adjoint A. So adjoint A is transpose of cofactor matrix. Whose cofactor? It is cofactor of matrix A, right? So transpose means writing rows as column. So row is there here, write it as column. C11, C12, C13 is the first row, write it as first column. C21, C22, C23 is the second row, write it as second column. C31, C32, C33 is the third row, write it as third column. So this is what cofactor adjoint A will be there, right? So this already you have studied this thing, right? There's no need to explain much about that. I'm just brushing the things here, then we can go for the trick. So for example, if A is P, Q, R, S, then what will be C11 means, here A11 is P, C11 will be its cofactor. What is C11? Leaving this row and this column, whatever determinant will be there, that will be C11, right? So that will be minor. From minor, if you calculate cofactor, you will get S. Similarly, cofactor of Q, you will get it as minus R. Cofactor of R, you will get it as minus Q. And cofactor of S, that is C22, you will get it as P. So cofactors may be denoted as Cij or it may be denoted as capital Aij. That is also possible. In some context, they will also define it as capital Aij. Here I have taken it as Cij, right? So C11, C12, C21, C22 is there. So C11 is S, C12 is minus R, C21 is minus Q, and C22 is P. So this is the cofactor matrix of given matrix A. So if I take transpose of this cofactor matrix, I will get adjoint for this particular matrix, which I have done here, right? First row S minus R, I have written as first column. Second row minus Q, P, I have written as second column. So this is how we are going to get the adjoint A through conventional method, as I said. So now take a moment, right? Pause this video, have a look at this. Then I will explain you the tricks with some examples. Okay, so have a look at this. friends, I hope you have noted it down. Okay, so let's see the trick. Okay, that was the conventional method. Now let's see trick how to arrive at the adjoint of any particular matrix. So let A be this matrix. We are asked to find the adjoint of this particular matrix. And remember, once we get the adjoint, it is very simple to find the inverse. Okay, so let's see how to find the adjoint of this particular matrix. So now the trick is, so the trick means it should be remembered, right? So you cannot find any connection for the how this came, how this, why this has to be written. That's nothing, that has got nothing to do with you, right? Just whatever I say, you remember the trick, then easily you will find the adjoint of any particular matrix. Okay, so given matrix is what? A, right? One. See, this given matrix, you write it as this thing: 1, 1, 1, 2, 1, minus 3, minus 1, 2, 3. Just without this symbol of matrix, you write down those rows and column. Okay. So after you write this, now we have to start using the trick. What is the trick? First step is reproduce these two rows as 4th and 5th row. This first row has to be written as 4th row, second row has to be written as 5th row. So this is 1, 1, 1, 4th row, and this one has to be written as second row. Second row has to be written as 5th row. Okay, so this is the first step. What is the first step? Our matrix was only this 3 rows and 3 columns. These 2 rows we have reproduced here as it is. Now next is these 2 columns, you reproduce it as it is. These 2 columns, you reproduce it as it is. 1, 2, minus 1, 1, 2. 1, 2, minus 1, 1, 2. So first column, you write it here. Then second column, 1, 1, 2, 1, 1. 1, 1, 2, 1, 1. So friends, it is clear, I hope. Our matrix was only this thing, right? Only this matrix was our matrix. So these 2 rows I have reproduced here, and these 2 columns I have reproduced here. I hope you have understood this one, right? So now let's begin. How to, out of this, how to find the A inverse. Put this way, right? First row and first column, you make it outside. You put a lines in this particular way. So now, here you need to form 9 boxes. How to form 9 boxes? Okay. First one is this box. These are 3 boxes. First box, second box, third box. Right? Similarly, here also you can form 3 boxes. 1, 2, 3. Right? So this is 4th box, 5th box, 6th box. Okay, and last one is this is the last box. So totally how many boxes we have got? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 black boxes in first row, 3 blue boxes in second row, and 3 green boxes in third row. Okay. So now you need to evaluate this. Okay. So adjoint of A will be equal to, okay, first box, write it in the form of determinant. 1 minus 3, 2, 3. Then here this determinant, that is minus 3, 2. I hope here it's not visible, so let's make it a little bit bigger. Okay, so adjoint of A is equal to, okay, write down first determinant. This box you write it in some form of determinant. 1, minus 3, 2, 3. This is first one. Second, this box minus 3, 2, 3, minus 1. And third one, this box, take it as third determinant. 2, 1, minus 1, 2. Okay. Now this is 3 determinants in first row. Then second row we have 3 boxes. Write them as 3 determinants. 2, 3, 1, 1. Second box is 3 minus 1, 1, 1. 3 minus 1, 1, 1. And third box is minus 1, 2, 1, 1. Minus 1, 2, 1, 1. Right. So second row is finished. Coming to third row. First box is 1, 1, 1, minus 3. 1, 1, 1, minus 3. This one, 1, 1, minus 3, 2. 1, 1, minus 3, 2. In this one, 1, 1, 2, 1. 1, 1, 2, 1. Right. So if you put it in this way and calculate this determinant's value, that will be your adjoint. So no need to calculate the value of minors and cofactors and take the transpose. That's all not needed. Just you need to remember this trick. Okay. See, 1 into 3 is 3, minus 2 into minus 3 is 1 into 3 is 3, 2 into minus 3 is minus 6. And here minus 3 into minus 1, that is 3, minus 3 into 2 is 6. And here 2 into 2 is 4, minus 1 into minus 1, minus 1. Right. And here 2 into 1 is 2, minus 3 into 1 is 3. And here 3 into 1 is 3, minus of 1 into minus 1 is minus 1. And here minus 1 into plus 1, minus 1, minus 1 into 2 is 2. And this part, 1 into minus 3, minus 3, minus 1. 1 into 2 is 2, minus of minus 3. And here 1 minus 2. Okay. So this will be what? 3 minus of minus 6 is 3 plus 6, that is 9. 3 minus 6 is minus 3. 4 minus of minus 1 plus 4 plus 1, 5. Minus 3, sorry, minus 1. 3 minus of minus 1, 4 minus 3 minus 4. This will be 5 minus 1. This will be our required adjoint A. So this is as simple. So here still I have gone in very detail, very slowly, but if you get practice at one stretch, simply you can get this value. There is no need to represent this determinant also. If you are able to identify the box directly, here you can calculate the values. Here you can write it 1 into 3 minus 2 into minus 3. Directly you can write this determinant. So I hope this method for calculating the adjoint is very much clear for you people. So you can take different problems where you have already found out the adjoint in your NCERTs. So take those problems itself and try to find the adjoint by this method. Then definitely you will be wondered how much time you will save in calculating this one. right? So as far as your JEE is concerned, so time is limited, so try to utilize these type of tricks. Okay, so right now we'll take a leave for this session. So in next upcoming session we'll come up with some more new interesting videos with interesting tricks. So stay tuned to my channel. If you have not subscribed, still you can subscribe and turn on the notification. Okay, so at this point we'll take a leave. Okay, take care, goodbye.